Hello and welcome to another episode of Some Gear No Idea. So this will be a different episode to usual. Instead of pulling something apart and repairing it, I'm going to be building a solution of sorts. So during Christmas, or for Christmas should I say, I got myself a fish tank. Now I used to keep fish years ago, but I decided that I wanted some fish in the office. So I wanted tropical fish, and with tropical fish they need heat. And what I did want was a way to monitor the temperature of the fish tank, because I didn't want sort of runaway heat, which can sometimes happen with heaters. They'll run away on their own. So I wanted a way of monitoring that temperature, and in time I want to be able to shut it off with a relay, but that comes later and possibly another project. For this particular project, I wanted a way to quickly glance at a reading or a readout to see what the temperature of the tank is. So I decided that the easiest way to do that would be to build something on an Arduino. So I'm going to be using one of these, which is an Arduino Nano. My screen's gone off on the camera, so I can't see. Let's just see if I can. It might shake. Let me see if I can tap it. There we go. An Arduino Nano. So that's what I'm going to be using to make this happen. And for the readout, I'm going to be using one of these LCD screens. Move that to one side. And for the temperature, I'm going to be using one of these DS probes. So it's a 3-wire temperature. So you've got positive, negative, if you will, and a data pin. So we'll also need a 4.7K resistor to go between the data line and the positive line, and I think that's for a pull-up for the Arduino. So that's what we're going to do. That's what we're going to attempt to put together. I have written some I've modified some code, added some of my own, but I'm not a programmer. A lot of the code was pre-written for these devices and this intended application. I think it's all open. I know it's all open source code, and I've modified it for my usage. So yeah, that's what we're going to do. We're going to put all these together, and hopefully coming up here, I'm going to have. I'll explain more going on, but I'm going to have two of these probes. One's going to measure the air, the room temperature, and the other one's just going to measure the tank temperature, and that'll be displayed clearly on this screen. So we'll talk about that as I put it all together. But yeah, so that's what we're doing. So hopefully 3 or 4 items, a bit of power, and we should have a working temperature indicator. So that's what we're doing. So let's crack on. So I just thought what I'd do is stick the Arduino under the microscope so you can see. It's a Mega 328P, and it's a Nano, and I got this from Amazon. So I thought I'll just quickly run it under the microscope so you can see the board. Unfortunately, obviously the microscope quality isn't the best. It's only a cheap microscope that is for repair, but it gives you the idea of the pins and the layout that you can see. That's a micro USB, so the one before the mini. So it is quite an old USB connector, and I don't think I can change it. Well, I possibly could. I'm not sure whether it's worth changing it or not. I have a lead for it, so I'll just use it. So yeah, I just thought I'd stick it under the microscope and show you the chips and a quick tour of the board. I'm going to solder the probes and the screen directly to the pins, so you'll get to see that coming up. Okay, so let's just start with this Arduino. So in order to get the screen working, you're going to need 4 wires. So plus 5 volts, whereas it might be 5.5, but plus 5 volts nonetheless, a ground, and 2 data pins, I think they are. On this particular Arduino, it's pins A4 and A5. So A4 is the SDA pin and A5 is the SCL pin. So I appreciate that it's going to be really small on here and you're not going to be able to see it. I might stick it under the microscope, but I did put, you know, I did do a microscope run just before this. So for me, with this USB on the right hand side, pins A4 on the top row and they're around about here. I haven't got anything to prod it with, I don't think. There we go. This will do. So it's these A4 and A5. So I'm going to solder the data pins to this, and 5.5 volts is here, and there's a ground here. So that's then the screen sorted. Then we've got these, and we're going to have to get a ground for this, 3.3 volts, which is here, and then we've got this yellow one, which is the data pin. If I recall correctly, and again I'd have to check, but I think that it might be one of the digital pins, but I'll have to check my notes for that. But obviously I'll show you when it comes down to soldering it, where it goes. It might even be A2 actually, now I come to think of it, but I'll check my notes when we come to solder it to make sure it's right. And at that point then we just have to upload some code to the Arduino to make it work. And I'll switch and I'll show you the code. I'll scroll through the code so you can see it, and then we'll update it and send it on its way. I'm gonna have to try and get my other microphone working. I've had to use a headset mic, so it's not great quality, unfortunately, but that's what I'll try and fix. So that's what we're going to do anyway. We're going to get this soldered up. I'll probably time lapse it just to get it done and dusted so the video's not too long, and then we'll move on to getting the code. Okie dokie, let's do that. Okay, so what I've done is I've took some of this like DuPont jumper wire. I've put some heat shrink on the end to make essentially a connector. Now I'm not too worried about colours, you know, it's not like it's being mass produced or anything, so it's only for me. But basically that will then snugly, if I can see with the camera, snugly kind of fit onto there. These will go around and then go into the various pins on the Arduino. Like I said, I'm not going to be, colours aren't too important, but obviously now it's set like this, I have to make sure that it's right. So in this case, red is ground, orange is VCC, yellow is SDA, and green is SCL. So what I'm going to do is I've stripped the other end, and I'm just going to whack some solder on this, just so they're nice and neat, and then I'm going to solder them into the right pins on the Arduino. So that's what we're going to do next. So, like I said, I'm going to just pop this on here, and we'll just go through the colours again. So, red is ground, VCC orange, SDA is yellow, and SCL is green. So, SDA, which I said is yellow, has to go on pin A4. So, let's just turn this around and see which one is A4. And that one is in there. Now I'm going to solder these one at a time, just so I make sure it's right. So I'll just I'll crack on and get that boxed off. Okay, so that's now complete. Those are all in. So we're ready now for the next one, which is going to be the temperature probes. So again, I've done the same thing. I've took some of this DuPont wire, jump wire, put a sleeve on the end, essentially to make a little connector. Now, it's not going on anything. It will be going on individual wires, but I'll have to figure this one out. I haven't quite figured it out properly yet. The reason is I want 2 temperature probes, and these go on like a 1-wire circuit, so it knows which temperature probe is kind of which, or there's some jiggery pokery anyway. But I need to do a couple of things. I need to put this resistor in between the 3.3 volts and the data pin. I need to get that in there, but also I need to put 2 temperature probes, and I wanted to try and make it so these things could pop out. So might take a bit more thought, and I'll figure that out shortly. I think what I'm tempted to do is get some the other side of these DuPont wires and solder both ends to one of for the data. Yeah, I haven't figured that bit out yet. So, but nonetheless, you know, these will need putting in anyway, and I need to bridge the wires with the solder. So, and then what I'll do is I'll wrap it in some heat shrink to protect it. So that's next on the list. Okay, so this is where we are. We have our Arduino with a bunch of wires coming off it. So we've got one for the screen and one for the sensors. So the sensors are going to 3.3 volts ground, and in this case on this board it's D2. So yeah, so that bit's soldering is done. On this side, we have 2 temperature probes, and I've soldered it onto some wires, and the resistor is between the 3.3 and the data pin, and it's all sandwiched together. It looks a bit of a mess because here is a zip tie, just to try and keep these all together nice. So if I just grab the screen, we'll have the screen plugs like so, and then these pins will plug into here. So purple and blue, and then 3.3 volts. So those will plug in, something like that. And then obviously I'll put some shrink wrap on this just to keep it all together. So that is the construction part of this project. So what we'll do now is we'll move on to the programming of the Arduino. So I'll show you the code that I've written. We'll get it uploaded and get it tested. So that's where we're going. Okay, so here we are again. So we're looking at the Arduino IDE on the Mac. I'm not going to go through setting up the actual Arduino. There are, you know, and I'll tell you why, is because, you know, there's lots of clones of these things that all require certain differences, only slightly, but certain differences, I would advise you, to ask a question on wherever you buy your Arduino from. What I will do is, for this particular one, I might just stick it in the description, the settings that I used, but otherwise I'm not really going to go through it. Another caveat is I'm not a programmer by any stretch. Some of this code I got from looking around the internet for liquid crystal displays. Some of it I actually got from the Amazon listing of the display. The temperature probe. Again, I just looked around the internet, and all I've done is I've configured the code for my requirements. But we'll go through it nonetheless anyway. But like I said, bits of it, what I say is probably wrong because I'm not a programmer. But let's go through it. So, at the top of your Arduino code, you're including these libraries, and the libraries of commands that control things like the LCD, control the one-wire circuit, and obviously the temperature. So these have the commands in to grab the temperature from the probe. This line is telling the Arduino where the LCD is, the address of the LCD, and that it's a 20 by 4. It's telling us that pin 2 or D2, I think on our case, where the one-wire circuit is, so the temperature probes. And then again, just to communicate on any device. So this is saying pass anything to the Dallas temperature sensor library, any references, and this is where it kind of starts. So it's initialize the LCD, turn on the backlight, and print a message. And these are all well commented. I didn't put these comments in. This is well commented by whomever constructed this code. So hats off to them. Unfortunately, I can't credit them because I don't know who it was. But it's open source. There was no copyrights anywhere that I could see, and I think Arduino itself is open source. So anyway, start the serial port to get the temperatures. So now we get into the bit where I've configured it. So the first line of text is just the tank temperature. So what is the temperature of the tank? And then it sets the cursor at place 18 on row 0 to put the Celsius sign, the little circle for the Celsius sign. And then move over to position 19 and set C for Celsius. The second line of text, I don't want anything because I want a gap. The third line or row of text, again, set the cursor to the beginning. This time I want to say room temperature because the second probe will, measure the temperature of the room, the ambient temperature, if you will. So set the cursor, and again we're doing the same thing, C and a degree sign and a C. And then the fourth row of text, fourth line of text, it's just almost a bit like a message of the day. Have you fed the fish today? Just a reminder. I would hope that moving forward, if I can modify it, maybe this will rotate, perhaps. I don't even know if that's possible, but I suppose anything's possible. You could put it maybe in a loop and say, every 10 seconds change that message or something, or flash that message perhaps. But this loop part is obviously the bit. So, above here is what I would refer to as static. And this is the loop. So this part of the code pretty much disappears off and says, get the reading for the temperature from one of the sensors, and then stick it at position 11 on the first row. It's got a 0 and a 1 at the end, and all this is each probe, because it's on the same wire. It says ignore the first one, go to the next one, or vice versa, or whatever. So again, just print the temperature, wait for 10 seconds, and then do it all again, and it will continue to do that as long as it's got power. So that's the code. Like I said, I'm not going to go through setting up the Arduino IDE. There's a ton of videos and documentation around it. But yeah, one thing I will add though, for some reason this board wasn't happy on my Mac. I couldn't get it to talk to the Mac at all. So in the end, I had to get a Windows laptop and just plug that in just to do the upload of the sketch. So yeah, I'm on Big Sur, so I don't know if that makes any difference, but yeah, it just wouldn't have it. You wouldn't see it. Even though I put the FTDI drivers on and messed around, and I consider myself to be quite proficient in computers, so you know, it's not. But yeah, and in the end, you know, it got to the point where I just couldn't be bothered messing with it anymore. I just wanted to get it sort of done and dusted and ready for the tank. So just moved over to a Windows laptop, and you know, it didn't take much after that. So anyway, let's move back to the camera and put all this together, and let's see what happens. Okay, so here we go. We have our screen, our programmed Arduino, and our temperature sensors. So what we need is some power. So like I said, this is the older style USB. So what should happen in theory is we plug this in and we should have something on the display. Oh, and just before I start, there is a little potentiometer on the back, and you need to adjust your contrast, because I think it's not right when it comes from the factory, so you have to adjust that because you might see nothing on the screen. So public service announcement for you. Here we go. Let's move that so you can see it actually. Here we go. Oh, just thinking about it. Okay, boo hiss. So we need to figure out what's wrong. So have we got? Maybe it's not. Maybe it's not in properly. Let's just check. Make sure our connections are good. Could be that we need to just you know, maybe touch these up. Let's give it another go. We've got power, and there we have it. So there must just be I might just have to touch it up with the solder. Yeah, there's definitely something not 100%. I think it might be this socket, to be honest. Yeah, I think. Yeah, I think there's a problem with my power supply. Yeah. Okay. So there's a little more work to do, but I did see something which was good. There we go. There you go. Let's so as you see it from the top, I know it's difficult to see. Let me see if I can turn the lights down. Let's have a go. That might be a little better, possibly. But yeah, you can see that the tank temperature, the room temperature, and then the little message on the bottom says feed the fish. I'll have to sort that. There's obviously a dodgy power connector, which is irritating. Let's see if we can get it back. Yeah, there's a dodgy power connector, so I'll fix that in a minute. But yeah, so that's actually working. So in theory, if I hold the sensors and you know, cradle the power, so I get a we should see those increase. And like I said, it's every 10 seconds, so we should see those rise because I've got hold of those sensors. There you go. So yes, success, which is good. So let's put the lights back on. Just grab the thing. So yeah, I think there's a dodgy. I think this power's dodgy, to be honest. I've had it for a long time, so. But what I will do is, regardless, is I'll just go along and just touch these up, just to make sure that they're 100%, and make sure there's no dry joints. So I'm just going to go over these, and then I'll come back to you. Okay, so this is the last kind of thing. So I've gone through and I've just touched up those points. It seems to be fine now. And what I've also done is made a little frame for it, just out of some scrap wood that I had. It's not perfect by any stretch, but what I'll do is I'm going to stain that wood, just to, you know, so it matches the other bits that are in the office. And then I'm going to remove the plastic cover for the LCD, so then it should be fine. And then I can adjust the contrast to where it needs to be. So I'll just switch the light off so you can get a, maybe you can see it. I'm trying to look at the camera screen, but I can't see. But if not, you'll just take my word for it that it's working as it should. That might be better. So there you have it, the Arduino fish tank and ambient room temperature monitor. Let me know if you have a go at making it. You can ask some questions. The trouble is, like I said, these Arduinos, there's a ton of them, so and not many are alike. So it'd be rare that I could answer your question, but feel free to try and ask, and you know, if I see it, I'll do my best to answer it. All of these I've got from either eBay or Amazon, and again, if I can find the links, I'll post them in the description. But and the code, I'll see if I can start an account on GitHub or something and stick that code on for anyone to take. But yeah, there you go. I hope you've enjoyed the video. I was hoping to do the Apple Magic Mouse, but unfortunately I was let down by an eBay seller, so I'm still waiting to find a sort of a donor for the one that I've took to bits, but that'll be coming in the future. There's no rush for that. So I'll just get this up and running and ready for the fish tank so I can get some fishing. And the next thing it will be, I want a Raspberry Pi version so I can then get alerts. So that'll be the next thing. And maybe even, you know, look at getting some motors on there, or not motors, sorry, relays rather, so I can, you know, stop the fish tank heater. You know, if it does start to go through the roof, maybe turn it off. So yeah, there's you know, this thing hopefully can be modified tons. But let's see where it goes. So like I said, I'm going to stain this, mount it up near the fish tank, and just try it out for a bit and see how it goes. So like, share, subscribe, do all of those things, and I will see you for the next one.